The video now is on different functions. The function that I chose, otherwise known as the parent function, is the cube root of x. After I toyed around with it or such like that, then I made a transform function. Going down to the graph, you can tell that my parent function is this function here. The graph is not gone to scale. After I transformed it, I got the equation -2 to the quantity of x cubed plus 2 in parentheses plus 1. You really have to be careful where you put your parentheses, because once you put it in the calculator, it gives you something completely different. Now, I use the calculator for this, but let's say your teacher says that you can't use the calculator. It's really good to know your different values, A's, B's, C's, and D's, or K and H's, and to know what they do. Since this right here is negative, then you're going to know that the graph is going to flip over whatever line is going to flip over. And since this number here, 2, since 2 is greater than 1, then you know your graph is going to narrow, or get narrower. X plus 2 tells you that the graph is going to move left 2. Keep in mind I said left 2, not right. And plus 1 is going to say that your graph is going to move up 1. Looking at the graph now, you can't really see these changes, but the graph is not drawn to scale. Talking about the different characteristics of a graph, such as domain, range, asymptotes, and end behavior. We'll start from end behavior. End behavior pretty much says, as x does something, as x increases or decreases, what is y doing? And as you can see, the equation here says, as x approaches infinity, y approaches infinity. Looking at the graph, you can tell that this is true. X increases and y increases. It's the same thing as x approaches negative infinity, y approaches negative infinity. So 9 times out of 10, when one thing approaches, the second one is approaching. X is also going to get to infinity before y does, so you could also put it in words and say, as x approaches infinity, y approaches infinity slower, but they're still going the same way. The asymptotes here are none. Cube root functions don't have any asymptotes. They never do. Now, the range. The range is all the available y values that a function can have. Also saying, as looking at the graph on the transform function, you can say the y values are also always on the y-axis, and as you can see, there's positive y values and negative y values. So the range is all real numbers. And for this type of graph, it will always be all real numbers. And the domain is the same as the range, except for there's all availability to the x values you can have in a function. And looking at the x-axis, you can tell that you have positive x's and negative x's. So the domain is also all real numbers. Looking at everything, it's really very handy that you know exactly what your variables are and what they all stand for. And this is how you transform a certain function. It's not very hard. It takes a little bit of it says you discuss the following characteristics. When discussing the characteristics in a function video, it's not sufficient to merely write down. As you're filling out a list for each characteristic, you must refer to the graph and explain how the graph illustrates each characteristic, which is how I did, but I didn't do that for the asymptote, but I'm hoping that he doesn't catch that. And pretty much that's all. So I know this is talking about this, but it's telling me to reconnect, and I don't understand why.